Good morning, students. Today I am going to teach you duality problem. This is a part of Unit 2. So, a linear programming problem with objective function of maximization or minimization can be changed from maximization to minimization or from minimization to maximization. So, what basically we are doing in duality problems, we are given a linear programming problem. We are converting this problem into another one. How? If the problem is given with the objective of maximization, we will convert it into minimization, and if the problem is given with minimization objective, we will convert it into maximization objective. So what is the main idea behind changing from primal to dual is to reduce the number of constraints and thereby the number of steps to obtain the optimal solution. So basically we are doing it to reduce the number of steps to get the optimal solution. Okay. The initial form of the problem in such cases is known as primal, and the form so obtained is known as the dual of the primal. So the initial form, the which is given in the question, is called primal, and the form so obtained is called dual of the primal. How will we convert it? To understand this, I have taken some cases. This is case 1. In case 1, you can see I have taken the objective is of minimization with all greater than equals to constraints. So the objective is minimize z equals to 6000 x1 plus 4000 x2. Subject to constraints, there are four constraints: 4x1 plus x2 greater than equals to 12, 9x1 plus 1x2 greater than equals to 20, 7x1 plus 3x2 greater than equals to 18. 10x1 plus 40x2 greater than equals to 40. So these are the four constraints, and the third is non-negativity condition, which says that x1 and x2 are greater than equals to 0. So this is a problem given in the question. What we have to do is we have to convert it into the dual of the primal. So how we will do it? There are some rules which we need to follow, like if in the primal the objective is minimization, the objective in dual will be maximization. Okay, the opposite of minimization. And you can see the alphabet which I have used after minimize is Z. In dual, the alphabet which we will use will be G. And you can see in primal there are two variables, x1 and x2. Okay, there are two variables in primal, x1 and x2. If there are two variables in primal, there will be two constraints in dual. You can see there are two constraints in the dual problem. What are these two constraints? 4y1 plus 9y2 plus 7y3 plus 10y4 less than equals to 6000, and the second is 1y1 plus 1y2 plus 3y3 plus 40y4 less than equals to 4000. So if there are two variables in the primal, there will be two constraints in the dual. You can see there are four constraints in primal. What are these constraints? 4x1 plus x2 greater than equals to 12, 9x1 plus x2 greater than equals to 20, 7x1 plus 3x2 greater than equals to 18, 10x1 plus 40x2 greater than equals to 40. So if there are four constraints in primal, there will be four new variables in the dual. You can see there are four new variables: y1, y2, y3, y4. So what are the rules? If there are the number of variables in the primal will be converted into number of constraints, and the number of constraints in the primal will be converted into number of variables. Okay, so how I have written these numbers, let's check it out. You can see in objective function it is written 6000 x1 plus 4000 x2, objective function of primal. These two numbers I have used in the right hand side of the constraints of dual. Okay, 6000 and 4000. And how will I write the constraints? You can see the numbers written in the first column of the constraints, that is 4, 9, 7, 10, will be now written in rows. Earlier they were written in column, now they will be written in rows. You can see 4y1 plus 9y2 plus 7y3 plus 10y4. So earlier the sign was of greater than equals to, now the sign is of less than equals to. Second constraint is, you can see in the constraints of primal, column wise values 1, 1, 3, 40. These values will turn out into the rows 1y1 plus 1y2 plus 3y3 plus 40y4 less than equals to 4000. I have taken this 4000 from the objective function of primal, and in the last I have written y1, y2, y3, y4 are greater than equals to 0. This is a non-negativity condition. So what are the points to be noted here? You can see in primal here involves minimization. The primal problem is of minimization and the dual problem is of maximization. Okay. Second point, the primal in primal we write objective function as z, in dual we write objective function as g. You can see in primal instead of g now we are using the word alphabet g. In primal the variables are x1 and x2. Dual has new set of variables y1, y2, y3, y4. Here the variables are x1 and x2. Here the new variables are y1, y2, y3, y4. Fourth point, primal has two variables x1 and x2. The dual therefore has two constraints. Here you can see we have two variables. Here we have two constraints. Primal has four constraints. The dual has four variables. Primal has four constraints 1, 2, 3, 4. And the dual has four variables y1, y2, y3, y4. In primal's objective function 6000 and 4000 are the coefficients. You can see 6000 and 4000 are the coefficients of primal, which in dual 6000 and 4000 become constants of constants on the right hand side. This 6000 and 4000 now we will write here as a constant in the right hand side. In primal, the coefficients of constraint column wise are 4, 9, 7, 10, 1, 1, 3, 40. Here you can see that 4, 9, 7, 10, 1, 1, 3, 40. In dual, each column takes a position row wise as under 4, 9, 7, 10, 1, 1, 3, 40. So these column wise values are written as row wise 4, 9, 7, 10, 1, 1, 3, 40. In primal, the signs of constraints are greater than or equals to. In dual, the sign of constraints are just the reverse, that is less than or equal to. You can see here the signs are greater than equals to, which are turned into less than equals to. So this was the case 1. Now I will take one more case today, that is case 2. In case 2 you can see the objective function of the primal will be of maximization with all less than equals to constraints. Okay, the problem is written here. The objective function is maximize z equals to 120x1 plus 30x2 plus 10x3 subject to constraints. There are three constraints: 10x1 plus 2x2 plus x3 less than equals to 100, 10x1 sorry 7x1 plus 3x2 plus 2x3 less than equals to 77, 2x1 plus 4x2 plus x3 less than equals to 80, and x1, x2, x3 are greater than equals to 0. So this is our primal problem. Now we have to convert it into dual. So the objective maximization will be converted into minimization. The word z will be converted into g. There how many constraints are there? 1, 2, 3. So if there are 3 constraints in primal, there will be 3 variables in the dual. You can see the 3 new variables are y1, y2, y3. And here there are x1, x2, x3, 3 variables. So there will be 3 constraints in dual. You can see first, second and third. Okay, so value we know how to write. 10, 7, 2. These are column wise values will be converted into row wise. 10, 7, 2, 2, 3, 4. you can see the second column is converted into second row, 2, 3, 4. Okay, and these values which are written on the right hand side of the constant of primal will be written in the objective function, as constants. Okay, 100y1 plus 77y2 plus 80y3, and these values we have taken from the objective function of primal, that is 120, 30 and 10, which we have written right hand side of the constants of the dual, and at the last we will write y1, y2, y3 is greater than equals to 0. This is our non-negativity condition. So I hope these two cases are clear to all of you. Thank you so much. I will come into the next video with other cases.